Well, today we're going to talk about Cortadera, which is a copper gold porphyry deposit in northern Chile, and the importance of basically getting the understanding of the 3D geometry plus the timing of the emplacement of several different stages of mineralized intrusion. So you could say it's a 4D approach, which assists in drilling your next hole, helps in resource modeling, resource expansion, and exploration in the district. So if you see the map, there's a study area there. We're in northern Chile, in the vicinity of Huasco, Vallenar, north of Santiago, in a belt that's largely lower Cretaceous stratified sedimentary rocks. We have two different ages of intrusions or copper porphyries in this area. In green, we see these early Cretaceous, and Cortadera is a late Cretaceous intrusion dated by shrimp zircon dating of about 91 million years old. And that's from start to finish. That's from early mineral to late and post-mineral dikes. All of tonalites all come within 91 million plus or minus 500,000 years. So they all happened at the same time with the resolution of 2 sigma on the shrimp dating technique. Now, the good news is that this has got very favorable infrastructure. It's located fairly close to a port, low altitude, about 1,200 meters above sea level, not like the high Andean, many other porphyry systems and gold systems in Chile. Near the coast, major roads, and it's quite interesting because historically, Productora, which is within 10 kilometers or so maybe 14 kilometers of Cortadera, that has a reasonable resource, 273 million tons at 0.52% copper equivalent. Cortadera just recently put out its maiden resource, which is going to get larger, of about double the size and similar sort of grades. So if we do a combined Cortadera and Productora resource, have about 3/4 billion tons at almost 0.5% copper equivalent for 3 million metric tons of copper and 2.7 million ounces of gold. Well, that's a good start. Now, if you wanted to know what it looks like, this is looking at the Cortadera Cuerpo system. They have 3 deposits, if you will, all along this quebrada, this stream that extends east-southeast, Cuerpos 1, 2, and 3, and that's over a strike length of 2.2 kilometers. Cuerpo 1 had been mined to some small extent historically. And then we're looking up at the higher mountains there, which are well over 3,000 meters above sea level. Again, this area there in that dry stream bed is only about 1,200 meters above sea level, less than 50 kilometers from the coast. Now, this is what you might see in one of the outcrops, sheeted quartz veinlets with goethite. And the goethite is typically after chalcopyrite and pyrite, hosted by, in this case, a tonalite porphyry. In drill core, you'll see more sheeted veins, not to give you the impression that there's only sheeted veins. There's multiple orientations, there's vein stockworks, and there's chalcopyrite and pyrite associated with the veins, fractures that cut through the veins, and replacing hornblende and other mafic phenocrysts in the wall rock. So this is a chalcopyrite, pyrite dominant porphyry system, as many of them are. Well, in terms of drill intercepts, things have gone pretty well. This is a list that Hot Chili has put together of the best published sort of copper drill results recorded since January 2018. So you have the main thing to look at is the hundreds of meters for the intervals, and then the copper and gold grades. And those in yellow are those from Cortadera. So they've done reasonably well, 972 meters at 0.5 copper and 0.2 gold. Which includes a higher grade zone, a higher grade core, 412 meters, this is in the best hole, of 0.7% copper and 0.3 grams per ton gold. So this is a porphyry, it's vertically extensive like some of the better ones are. And of course, these are individual photos showing you bits of, again, it's higher grade zones, over percent copper, 0.4 to 0.6 grams per ton gold. You can get up to high grades of 0.9% copper over tens of meters, perhaps even over 100 meters, and 0.4, 0.5 gold. This has ability so some of it's near surface, some of it's at depth. You could do a combined open pit and underground block cave scenario. And Hot Chili wishes to point out that these grades and the size is competitive, with Cadia East, with Candelaria. And they'll even, if you go to their website, they put out talks that compares the grade, tonnage, size, potential economics of these systems, and Cortadera compares favorably, particularly if you bring in the sphere of influence of Productora. It's quite a large operation, potentially. So what we did when I came on about 2 years ago was apparent from all the good work the team had done that we could put together a pretty useful model. And the purpose of making this model was to find more. There's been a lot more drilling put in since I started with the group, and they've been very focused. By having this model, we've been able to predict where to drill holes and then revise the model. With each additional hole, we got smarter. And we do this with Leapfrog. You could do it with other 3D modeling packages. Leapfrog is just very useful, and it can update itself on the fly with each additional data without the pain of re-wireframing and digitizing new services. It's quite useful. So what inputs did we use? Well, we took all the drilling and surface data, mapping data, soil sampling, rock chip. We looked at the lithology downhole and those mapped at surface, and we linked them up. And we could do this in many systems. There's always a porphyry that comes early, and in many systems, that porphyry brings the metals to the party. He brought the copper, he brought the gold, or it. Okay, let's not make it a man or a woman. But then as subsequent porphyries come to the party, they bring less metals. And then eventually you get the very late porphyries that often shut down the party and often call the police, and everything's gone. These are the barren dikes. Fortunately, in many porphyry systems, late barren systems are small. Unfortunately, in some others, they stope out and dilute the system. So the team has broken out a series of intrusions, and it's based largely upon the vein paragenesis. So you might have an early intrusion that has all the veins you've seen, from early hot veins, we'll call them A veins, through transitional brittle veins, we'll call them B veins, to later chalcopyrite, pyrite-rich metal veins, we'll call C veins, to late D veins, which are basically pyrite with some quartz and lots of feldspar to destructive alteration in the halos. And some early intrusions be affected by all those veins. Later intrusions won't have the early veins. They won't have the A or B veins, but they might have the C or the D veins. So one can break out a chronology, and that's what's been done. We looked at the abundance of quartz veining, which is very important because these cracks that are filled by quartz are often filled by copper, chalcopyrite and pyrite, and reopened by subsequent metal-rich veins. So there's a good empirical relationship of quartz vein abundance to copper and gold grades. We look at the chalcopyrite-pyrite ratio. The greater that ratio, the closer you are into the guts of the system where there's more copper. We have surface geochemistry, downhole from assay data. We make zoning models. And I'll show you just a couple here just for copper and molybdenum, but you can do it for lots of different elements. We also integrated the geophysics, surface topography, and importantly is this time extent. So 3D becomes 4D by bringing in the different stages of intrusions. And I'll show you that in a moment. Okay, so we're not doing this for the sake of making a beautiful model. We are doing this to come out with a chronological geological model, from the early intrusions, which are the causal mineralizers, to the transitional intrusions that brought less metals to the party, to the late dikes that are low grade, but reopen often high grade mineralized corridors. So we want to follow those late dikes into the systems. We've made a vein abundance model. We've done various isosurfaces for the distribution of copper, gold, silver, moly, zinc, and particularly the gold over copper or copper over zinc ratios are useful. Gold over copper ratios can often break out different intrusive phases for you. The copper over zinc often tells you about where the hot spot is. If the mineralogy is fairly simple, copper occurs in chalcopyrite and zinc occurs in sphalerite. Copper in chalcopyrite indicates higher levels of deposition than zinc does in sphalerite. So it's essentially a thermometer saying higher copper over zinc, this is higher, hotter portion of the system. The chalcopyrite-pyrite ratio isosurfaces are useful too. We've done magnetic susceptibility models. We've even used some of the ASD data and calculated mineralogy to help us determine chlorite white mica ratio models, which can be useful for metal metallurgy. So if you have too much white mica, that might inhibit flotation of sulfides. So you want to have a reasonable chloride over white mica ratio. And of course, all of this is about developing drill targets, extending and finding ore, expanding and defining your resource. That's why we do this. So here's a view looking downwards. The scale bar there is 500 meters, and that's about a 2.2 kilometer extent trending northwest. And there's 3 major ore zones to date: Cuerpo 1, 2, and 3. Cuerpo 4 needs some more holes in it. In yellow, you have these late porphyry dikes. These came late to the party. They're not barren. There are some later andesite dikes, which we can see in the middle of the screen, where through this flag that says Cuerpo 2, those blue dikes, they're andesite, they're 40 series, and they are pretty much barren. But these late dikes are useful because they outcrop and they continue up to the north and south, and they not only show a northwest corridor, but they show these north-south corridors, which is only something that's been really well documented in the last 2 years. And so what they've helped us do is they've helped us extend some of the ore out towards the north, which has been picked up upon by this late dike swarm. And there's earlier phases of intrusion, the intramineral 20 series in red, and then the purple or magenta, early causal intrusion that brings most of the metals to party. There are proximal bedding destructive, we say skarns, and yes, they are skarns, but don't think about skarn style mineralization. They've got a little bit of garnet, but typically epidote chlorite, biotite, and there are high temperature hornfells that destroys the bedding in the surrounding volcanic and sedimentary rocks. And then the more distal skarns in blue, you can still recognize the bedding. But that heating up, that hornfells or skarn event is really pre-ore. It's like the thermal front that was just ahead of the vein front and the fracture front that was related to these intrusions of these mineralized intrusions. So again, looking down on an aerial photograph, you can see in yellow, there's the greater than 0.1% copper outline, not copper equivalent, just copper, projected to surface. You can see the drill hole traces. And then in magenta is the greater than 0.4% copper, which might come out to be more like 0.6%, 0.55% copper equivalent, is a higher grade core. And this is out of a press release made in March, so you can go ahead and see various holes, the sort of hundreds of meters of 0.4, 0.1, 0.5, 0.2 copper gold. There's the JORC compliant resource. So you've got almost 2 million ounces of gold as a byproduct to 1.7 million metric tons of copper. So most of the value of this deposit is in the copper. And if you want to put it back to equivalent gold, it's very large. I'm going to do the sums right now. It'd probably be on the order of, I don't know, 8 million ounces. Someone will have to figure that out. And it's got byproduct silver and molybdenum as well. So this is a long section looking towards the northeast. So Cuerpo 1 in the northwest is on your left, Cuerpo 3 in the southeast is on your right. And the yellow outlines are the 0.1% copper model, and the magenta is the 0.4%. You can see where the drill holes are. And this is, somewhat a promotional slide. It's saying, look, why not go down and go to the side, because these things still are open. So that's of interest. Again, the geometry is quite interesting. The scale's important. Those graph grids are 500 meters. So we've got a 1.2 kilometer tall zone that's been drilled at Cuerpo 3. And these porphyries can be vertically extensive. So you don't need that much in your X and Y, your horizontal footprint. When you run it by a kilometer down the ore column, it gives you significant tonnage and contained metal. This is a plan view on the left that is showing molybdenum, all right? And so you see there's 40 ppm, 25 ppm. It's showing these late dikes, the late north-south porphyry dikes, the 30 series, the guys that came late to the party, but there's still a little metal. And we're seeing some targets. Cuerpo 3 North target is something that the company's been pursuing. And prior to recognizing this north-south corridor, there was more of a focus on the obvious northwestern. But we've determined that in most of these cuerpos, there's a 30 or later andesite dike, 40 series north-south are running through. So these are making the beads along the string. In this case, we have a pearl necklace, and we're extending it out northwest and southeast. And the location of each lozenge or a pearl, which can be a kilometer vertically down in the case of Cuerpo 3, is controlled by cross structures, northerly trending cross structures. And we can see the moly makes a nice kind of halo. A nice halo around Cuerpo 1, a bit of a tiny halo around Cuerpo 3 and Cuerpo 2. And we'll see this in cross-section later. But, you know, moly at 40 ppm. So in other words, what this means is just in the halo of a high-grade copper, you know, let's say just as you're going from maybe 0.5 to 0.4 copper and then getting out to 0.4 to 0.3 copper, you get this moly halo. So it's overlapping with the ore. It's also coincident with gypsum, or I should say anhydrite veins, and we'll talk more about that in the latter part of this talk. On the right-hand diagram, you're seeing a depth slice from the IP chargeability, so presumably telling you mostly about pyrite. And then we're seeing the quartz vein abundance modeled from the drilling. You can see there's a pretty good relationship. So what we have is a fairly chargeable cap. We've got more pyrite up high in the system, more chalcopyrite deeper down, particularly to Cuerpo 3 on the southeast. But there's also pyrite in the ore body too. So there's a reasonable relationship of chargeability apparently sitting on top. So again, moly, here the chargeability and the porphyry style quartz vein abundance all bring you into the ore zones. So going back to the model, again, now you can see in Cuerpo 2, those blue north-south 40 series barren, very low-grade dikes. We're going to show you some cross sections and long sections, A, B, and C. So I think the first one is C. So C is mislabeled. That should be west-northwest and east-southeast. So you're looking towards the northeast. And now we're seeing the 1% copper. We're seeing the 4% copper, 0.4% copper, 0.1% copper. And it's about a 100-meter wide slice, okay? So you're seeing the copper percent in drill hole, color-coded as per the legend. And then you're seeing these outlines. So that's kind of our basis. And then we're showing you drill hole 13, which was 750 meters of 0.6 copper, 0.2 gold, including some higher grade zones of 200 meters of 0.9 copper, 0.4 gold. Now we'll go to the next section. And now this is just basically some copper isosurfaces. This itself is not the ore resource or block model. This is just using Leapfrog to make some contours, which you could do as you would continually do when you're exploring and targeting drill holes. And you can see, in this slice, there is room for more drilling, obviously. I'm looking at Cuerpo 3. You see the high grade hole there near 13D, and you step off towards the left or the west. And on this section in 100 meters, we need to put in some more holes. So this thing is definitely not closed. Okay, you can also see it's open down here being to the sort of southeast side of Cuerpo 3 at depths around, let me just see what just above 0 meter RL. So again, this is 1.2 kilometers you're looking at, or a kilometer ore column. Now, this is molybdenum, which it looks a little funny in long section, but still the point is at Cuerpo 1, look at the moly lobes on the outside of the higher grade. Again, the drill holes are color-coded by copper, and we've used Leapfrog to help us make isosurfaces for the moly. So again, there's a moly footwall and wrapping around Cuerpo 2 in this particular long section with a 100-meter wide slice for the drilling, but this is the isosurfaces just as they intersect the center of the long section. So we're seeing drilling off section, and we're seeing the moly slice right on the section. And then there you can even see this sort of big zone on this particular slice. It looks to be like a lot of moly. And you'll see through the cross section that actually there's a lower grade center that's sitting in just behind this slice. Lower grade moly, but higher grade copper and gold. This is quartz vein abundance. And again, you can see, we're talking 10% veins, all right, in purple and 5% in red. So again, you can see the good relationship of veins. And the neat thing is you see the halo, a halo of like 2% veins going around kind of the outside. So once you start intersecting more than 1%, 2% veins, you can say, hey, I better keep drilling because I'm going to get into something. All right, and this is, again, a wafer-thin slice of the geology through this long section. And important things to look at are the magenta early 10 series. They're the guys that brought most of the metals to the party, followed by the fellow that came a little bit later. Maybe he didn't bring the keg of beer. Maybe he brought a few bottles of wine, but they're good wine. And this does have some grade too. All right, so these are the 20 series in red. And then we start getting into these narrow 30 series dikes, which are generally north-south and northwest. And they're lower grade. And we're not showing the 40 series dikes. There's a few of them in Cuerpo too. They're volumetrically insignificant. And we can see in blue, these are sedimentary rocks. In dark green, volcanics. And then we have this sort of pale green proximal bedding destroyed hornfells, and in blue, a little more distal bedding preserved hornfells. So again, when you start getting hornfells, hey, I'm getting close to something. Oh, I can still see the bedding. Let's keep drilling. Ooh, I can't see the bedding anymore. We're getting really close to a causal intrusion. We're close to a 10 or 20 series intrusion. And if I start seeing texture destroyed in my hornfells after volcanic clastic rocks or sedimentary rocks, and I start seeing 1% veins, and I start seeing a little bit of chalco, I keep drilling. I drill through a moly halo, I get into a copper gold-rich core. So we'll go ahead and look at AA prime now. This is Cuerpo 2. And so A is to the south, and A prime is to the north. And on the left, we see the copper isosurfaces. Again, this is 200-meter wide slice. So we're trying to bring in a lot of drill holes just to show you, but the actual isosurfaces are directly in the plane of the section, and the drill holes are plus or minus 100 meters each side. So again, you can see obviously there's some bit of grade. You can see the 0.7, 0.5, larger point, greater than 0.3% copper. There's a good example of the moly halo around the outside. And this is, you can see visible moly on fractures. You don't have to wait for your assays to come back. To the left is the quartz vein abundance. Not a bad agreement with the copper grades. You can see there is a bit of quartz going down below where there's copper, and it's probably likely due to earlier veins that came early to the party when you were depositing mostly magnetite and not so much chalcopyrite. And on the right-hand side is a bit of a model showing you the high-grade core and the 0.1% model around the outside. Now let's go to the, oh, sorry, not yet. This is now the geology. Now we can see the gentle southerly dips of the volcanics in green, the sediments in light blue, with the causal intrusion early 10 series, followed by the inframineral 20 series, small little yellow 30 series dikes. We have some proximal texture destroyed hornfells, and then we have the more distal texture preserved hornfells or distal scarring. So it's important you understand how everything works together, and it's easier to find more. So now let's go to the big one. Let's go to the almost 500 million ton ore body that's recently been released in a resource, and it's getting bigger, Cuerpo 3. Here we're looking northwest, and we see a significant amount above 0.5%, even a higher grade core, 0.7% copper. On the right, look at that lovely moly halo. It overlaps with ore, but the real high grade stuff in the center is a little bit lower moly. This is very useful, and this corresponds with moly on fractures and anhydrite, a halo of anhydrite veins around the higher grade core. Quartz vein abundance does it for you too. 0.2, 0.3, 0.5, 10% quartz veins, good relationship to grade. And then on the right, we can see the sort of high grade core is modeled and the 0.1% outline. And in geology, we again see this sort of southerly dip and the various near light green texture destroyed hornfells, the bluer texture preserved hornfells, the pink magenta early mineral porphyry, the 10 series, 20 series intramineral porphyry. And here's the dikes in yellow with a little bit of a dike eye in this one zone here, a little clot of late mineral lower grade material. Now, we're working on calculated mineralogy. This is something that Scott Halley's helping us with. This is people like Ron Berry and Angela Escalme, who are at Codes in Tasmania, do a lot of good work on. You basically take the geochemistry, maybe feed in some ASD, terrace spec results, magnetic susceptibility, visual logging perhaps, and you determine what the minerals are, potentially. Again, this is not a bad start. You can see from sight on the left, there's basically our oxidized zone. There's 1,500 meters above sea level up here, top of the ore body around 1,200 meters, going down to sea level at the bottom of the page. And we see the logging's pretty simple. There's the 0.1% copper model, high grade at 0.4%, chloride on the wings, bits of albite, but generally a lot of phyllic alteration with little bits of biotite and chloride. So, you know, it's sure we could push that further, but there's a lot of sericite in this deposit. This is where the calculated mineralogy helps us a bit. This cross section is a little bit rotated. It's 15 degrees rotated off the one on the left, the one on the right, but it's pretty similar. You can see some of the same holes. That's drill hole 13, one of the deeper holes on the project for reference. And we can see you have chlorite. What's pale green on the top is greater than 4.5% weight percent chloride, according to Scott Halley's calculated mineralogy. And so that's all the stuff that's green, some up top and some at the bottom. Biotite is greater than 4.7 weight percent biotite. Clearly at the bottom. Up top, this might be biotite. It also might be a type of chlorite. So, you know, this is where some visual logging would be helpful. Although we do find a little bits of biotite, relic biotite that haven't been overprinted by phyllic alteration locally in the top in Cuerpo 2. This is Cuerpo 3, so it's possible. We have in yellow the sericite greater than 3.8%. You see it makes up a large part and overprints the chlorite. There's in blue is anhydrite greater than 5.2 weight percent. And this forms the wings, not unlike a molybdenum halo. And then albite, which is more than 30% albite. So this does seem to be a significant component. It's often very hard to log this, but it comes out of the calculated mineralogy with the excess of sodium. So if we integrate this a bit, we see on top, we have a sericite chloride zone and sericite chloride down towards the bottom. And this is what many people would call, well, particularly if there's some clay associated with it, intermediate argillic. It might be slightly higher temperature with the classic intermediate argillic, but the point is it's green, gray clay. And this is very common in certain porphyry systems. And in this case, it's associated with a good bit of copper and gold. Going downwards, you can see there's also gold associated with this phyllic alteration, the albite, and we still have some gaps in our model. And that just means we haven't accounted, we haven't really used all the data, and we're still working on that. We're rerunning a version of this calculated mineralogy. In fact, Scott's going to talk to us on Thursday. We're going to update this. So it's helpful. But it's fairly common that this is a system that's not all about the potassic zone. This system is about the chlorite, sericite, and the sericite overprint, because that's when the copper and gold were deposited. In the potassic zone, we generally have, there's not much, it's largely overprinted, but we have relic magnetite. In this overprint zone where chloride is stable, we can have magnetite stable with chlorite, stable with chalcopyrite and pyrite. In the sericite zone, typically we lose the chlorite, we lose the magnetite, but there's still chalcopyrite and pyrite. All right, so basically the chalcopyrite and pyrite came in the transitional stage and is associated with sericite and chlorite, not in the early stage with the high temperature biotite. Okay, so now for a little bit of promotion. So there's a little bit of the science, and then we'll I'll show you, how I've been being optimistic and comparing Cortadera to a deposit I'm very familiar with and I've helped grow for the past several years with Sol Gold as their chief technical advisor, going to Ecuador up to 5 times a year until recently. And this is the Alpala deposit, which is gigantic. It's depending on what cutoff you want to use, it's got 20 million ounces of gold and 10 million tons of copper. It's just incredible. And 100 million ounces of silver. But there's some similarities between Apala and Cortadera, and that's what got me very encouraged when Christian Easterday approached me, managing director of Hot Chili, and said, look at this core. And I said, wow, this looks familiar. So this is the Cuerpo 1, 2, and 4 we've been discussing. Magenta is 0.4 and yellow is 0.1 copper. And there's just taking the 0.2% copper outline projected to the surface. I'm going to compare this to the 0.2% copper outline for Apala. Okay, and keep in mind, Apala is 3 billion tons at 0.52 copper equivalent if you use the 0.2 cutoff. It's 420 million tons at 1.5% copper equivalent using a 0.9 cutoff. It's got a very high grade core. So the strike extent of Apala is about the same as the strike extent of Cuerpos 1 through 3. Apala is winning on the width, and it probably will continue to do so. But the point is that there's still room to drill holes to enlarge the Cortadera discovery, and that's what's happening now, and you will get an updated resource later on this year. And of course at depth. And so if you look at a long section here, on the left it's the Cascabel Ecuador long section, and you see the scale bar there, 500 meters. So those horizontal lines are giving you 1.5 kilometers of ore column depth. And you can see the 0.3 outline in blue and the 0.9 outline, okay? And you can see this sort of gentle body plunging off to the northwest, which is related to these purple, magenta, and yellow intrusions. They're the early guys that came to the party. And then these D15 is this intramineral that came later, still has grade, but not as high a grade. Now here's a long section for Cortadera, stressing there's very limited drilling at depth and showing you one of the better drill holes. And so it's much closer to surface than Apala, which is good news. And it does show that, you know, if you had an ore column like Apala, you could expect to go deeper or certainly laterally. So there's been more focus recently to drill in between Cuerpos 2 and 3, and there'll be more work between Cuerpos 1, following these at depth as well. Keep in mind, you're seeing a lot of holes here, but there's gaps in these holes at depth and to the side, because this has got a very large window that's being projected in. In cross-section, sort of similar in that we're looking at the same scale for Apala, with the, you know, the surface here roughly equivalent to the surface of Apala. And the good news is you have higher grade ore closer to surface at Cortadera than you do at Apala. And there's the sort of size of the 420 million tons at 1.5% copper at Apala, and what we're getting here in the Cuerpo 3, higher grade core. And this is what really needs to be derived and it filled in, of course, more drilling on each side and the depth. Because if you do go underground, you're going to need that early high grade, and that's important for getting early payback. Okay, let's step back a bit and towards the last few slides of our talk and talk about, well, how do you use this in a bigger picture? So Cuerpos 1 through 4 have been discovered. Here they are showing as some of them are discrete magnetic highs. It's sitting on a mag map, which is, I'm not certain, to be honest. I've forgotten if this is an RTP or a TMI map, but we will say what's hot in colors is magnetic, or relatively magnetic with respect to interaction with the Earth's magnetic field, and what's blue is low or very low magnetism. And so you can see there's a nice little blip there on Cuerpos 2 and 4, and yes, there is magnetite in the drill core, whereas Cuerpos 1 and 3, particularly 3, a lot of that magnetite's been overprinted and sulfidized and replaced by chalcopyrite and pyrite. So you have a nice big feature. You could say there's a big zone of demagnetization, I would say, in general, maybe pierced by some bits of hydrothermal magnetite associated with early intrusions. Now, let's just go again, and I'll throw this back to Apala, because Apala is a 3 billion ton ore body, just to show that you can fit this in and to think about, just because the initial resource is 500 million tons, you know, that doesn't mean that's where it will finish. Apala started off at a third the size it is now, and just more drilling added to it. So this is basically magnetite destructive alteration from drilling and from 50-meter space line spacing on ground mag and air mag. It looks like a bit like this. If you were to take the exact same scale and throw it on top with north being up the page, that's what it would look like. This is the magnetite destructive fill alteration mapped at surface. So this is where you have a dominantly quartz sericite pyrite, magnetite's been destroyed. Also north is north, so it just happens to be, it shares a very similar orientation to Cortadera. And again, you can see the size of the system. That's what I'm just getting about. Think about the footprint and how it fits with other large deposits. And there's the Apollo at greater 0.4% copper equivalent. I think this is the final slide or close to the final slide. This is, again, looking down in a map of the IP chargeability depth slice at about 300 meters below surface. So you see all that chargeable material on top of the cuerpos, which has a 0.1% copper model envelope for help you register. And some of the areas that the company's drilling going off towards the southeast, the Cuerpo 3 high-grade core extension. Cuerpo 3 north, I showed you that north-south dike swarm, the gap zone between Cuerpo 3 and Cuerpo 2. Still some drilling going on in Cuerpo 1 and 4, it's open. And most interesting, soils. Down, when up to about a year and a half ago or 2 years ago, the soil grid stopped here. There were soils over the Cuerpos and it stopped here. And we saw this 2.3 ppm sort of contour that fit pretty well, a little bit of off-centered, I should say. Remember, moly core forms a halo. So it's a little bit just to the side and overlapping the ore at depth. So the decision was made based upon this relationship of molybdenum and the fact that there were some dikes, north-south dikes mapped up here by previous explorers, that this area should be soil sampled. So the lines were continued. And the moly here came back a bit higher, but at 4.8 ppm, you got a lovely moly target, which is slightly displaced from the IP high. Very similar to what was found down here in the Cuerpos, where we know there's quite a bit of ore, over 500 million tons or so below it. So it made sense to go up here and have a look in the north. I went up there and mapped it, found more of these late dikes, found alteration, found epidote veins, found some B-type quartz veins. Very interesting. Found secondary copper. Now this has led to an RC program. And you can see where the holes are planned and have been put in these white triangles. So this is using the model we've made at Opala to explore a couple kilometers to the north for a potential other porphyry system. And this is looking interesting. It looks like we're higher in the system than Apollo, so it's not outcropping like it is. I'm saying Apollo, I'm sorry. I mean, Cuerpos 1, 2, and 3 at Cortadera. I think there's perhaps 500 meters more rock on top up to the north, but we'll see. And the drilling, it needs to have some diamond tails to the RC to determine the level of this porphyry system to the north. So I'll finish with that. I've lost track of time. With a view again, looking down, looking towards the southeast on Cortadera Porphyry system. Thank you for your patience.